Hello students, welcome to the session 7 of the chapter Solutions. In the previous session, we have seen what happens to the molarity of a solution when I dilute it. In today's session, we are going to see what happens to the molarity of a solution when I mix two solutions of different molarities. Let us see how to do it. I have taken a solution of molarity M1. I have taken other solution of molarity M2. But please remember that both of them should be the solutions of the same compound. For example, if I am taking aqueous NaOH here, I will be taking aqueous NaOH even here. Okay, we should be mixing the same type of solution but having different molarities. Okay, here the molarity of this solution is M1, the molarity of this solution is M2. Okay, let us take the molarity here as 0.2 molar. Okay, let us imagine the molarity here is equal to 0.3 molar. So I have taken two solutions of different molarities. Okay, now let us take volume also. Here let me assume the volume to be 250 ml. Here let me assume the volume to be 450 ml. Okay, now I have two beakers with two solutions of different molarity. Now I will try to mix these two solutions. So what am I trying to do? I will try to mix these two solutions and get a resultant solution. Now the resultant solution will have some molarity. Definitely it will not be equal to M1 or M2. The resultant solution will have a different molarity, and that molarity, let me call it as final molarity. Now how should I get the final molarity? Okay, if you people are thinking, it is very easy. Let me add 0.2 plus 0.3 and I'll get 0.5. Then it is absolutely wrong. Okay, you cannot directly add the molarities of two solutions and get the molarity of the resultant solution, which is absolutely wrong. So what is your first understanding here? Molarities of two solutions cannot be added or subtracted. Okay, fine. Molarities cannot be added and subtracted. Okay, fine. This point we will remember. Now come to volume here. Volume of this solution is 250 ml and volume of this solution is 450 ml. When I mix both the solutions, what will be my final volume here? 250 plus 450, which will be equal to 700 ml. Volumes can be added. Okay. Now what else can be added? Imagine here the number of moles of this solution is N1. The number of moles of this solution be N2. Then I can add N1 plus N2 and I can get the final number of moles. We can even add number of moles of both the solutions to get the final number of moles. We can add volume of these two solutions to get the final volume, but you can never add or subtract the molarities to get the final molarity. So what should we conclude from here? Molarities of two solutions cannot be added or subtracted, but volumes and moles can be added. So here, if I want to write the final number of moles, how will I write it? Final number of moles is equal to N1 plus N2. Final volume will be equal to V1 plus V2. Okay, so these can be added. So I can get my final number of moles by just adding them. I can get my final volume by just adding them. But I can never get my final molarity by just adding them. Now, you people know the formula of molarity. We have been doing molarity in lot of detailing. So here, my final molarity, what is the formula of molarity? Okay, number of moles divided by volume of the number of moles of solute divided by volume of the solution. So molarity is equal to number of moles divided by volume. So how will I calculate the final molarity of the solution? By dividing total number of moles by volume of final volume. So I can get my final molarity by dividing the final number of moles by final volume. Okay, you cannot directly add and calculate the molarity, but you can divide the total number of moles by total volume and then I can get my final molarity. Okay, so now in the question you have been given molarity of this solution, you have been given molarity of other solution, but they didn't give you the number of moles of the solution. If he has given, you can directly add it, it's not a problem. For example, final molarity is equal to N1 plus N2 divided by V1 plus V2. This is how I can get my final molarity. But in general, if you see here, number of moles are not given in the question. Mostly they give the molarities and the volumes of the two solutions. Then what can I do? I can, instead of writing N1 and N2, I can write M1 V1, because we know number of moles is equal to molarity into volume. Okay, so instead of writing in terms of moles, let us write in terms of M into V. So then what will be my formula? Final molarity is equal to M1 V1 plus M2 V2 divided by V1 plus V2. So this is how I can calculate the final molarity of a solution which is obtained by mixing two solutions of different molarities. Final molarity is equal to M1 V1 plus M2 V2 divided by V1 plus V2. So using this formula, we can get the final molarity of the solution, because we cannot get the final molarity by just adding the individual molarities of the two solutions involved in the mixing. So this is about the molarity on mixing of the solutions and the formula we use to calculate molarity of the final solution obtained by mixing two different solutions. Now, to get an even better understanding, let us solve a numerical on this so that you get this concept better. Now, let's do a numerical on this concept. Okay, this is a numerical. Let's solve it. 0.1 molar 400 ml NaOH is mixed with 800 ml 0.4 m NaOH solution. Calculate the molarity of the resultant mixture. As I already told you people, we will not mix NaOH plus some H2SO4 and calculate the resultant molarity. We will never do that. We will just mix similar compound solution, but both of them will have different molarity. It's not like that I'll mix 0.1 m NaOH with 0.2 molar H2SO4. That is not what we are trying to do. Similar compound solution only we are trying to mix, but they have different concentrations. So if you see here, I have a solution. Okay, molarity is 0.1 molar and volume here is 400 ml. So my M1 is equal to 0.1 molar, V1 is equal to 400 ml. And I'm mixing this solution, okay, with other solution whose molarity is 0.4 molar and volume is equal to 800 ml. Okay, when I add both of them, I will get a resultant solution. Now we need to find out the molarity of the resultant solution. Volume we can directly add here and write down. Final volume 400 plus 800 ml. So it will be equal to 1200 ml. So to calculate the final molarity, what is the formula I have? Final molarity is equal to N1 plus N2 divided by V1 plus V2. But I already told you people, we are not directly given the number of moles. So first let us try to find the number of moles and then substitute here. So I need to get N1 from here, I need to get N2 from here. Not directly given, but we can find out, right? N1 is equal to M1 V1. I told you when I was deriving that formula only. N2 is equal to M2 into V2. Now let us substitute. N1 is equal to 0.1 into 400. Now if you are taking volume in ml and doing the calculation, you will not get moles but you will get millimoles. So I will just write it as millimoles because I am keeping the volume in ml. Okay, I just want to make you aware of millimoles also. So just we'll try to keep it as millimoles because the volume is there in ml. When you take the volume in ml, the moles you are getting will be your millimoles because this we are taking in milliliter. So millimoles is equal to 40 into 10 to the power of minus 3 millimoles. How many millimoles? Okay, so it will be equal to 40 millimoles. It will be equal to 40 millimoles. Now, let us try to convert this millimoles into moles. How do I convert millimoles into moles? How do I convert milliliter into liter? Multiplying with 10 to the power of minus 3. In the same way, how do I convert millimoles to moles? By multiplying it with 10 to the power of minus 3. because ultimately for substituting in this formula I can't deal in millimoles, so I'm just converting millimoles into moles. You can do it in the other way also. You can convert volume into liters here and directly get the moles. Okay, you can directly convert 400 ml into liters and directly get the moles by substituting volume in liter in this formula. I just wanted to tell you people the concept of millimoles also, so I have just converted into converted millimoles into moles at the end by taking volume in milliliter, which is given in the question, or directly convert volume here only into liters and just substitute the volume here. Anything is fine. Okay, now let me calculate the number of millimoles here. 0.4 into 800 ml. So here I get millimoles, which will be equal to 320 millimoles. So how many millimoles I will be getting here? 320 millimoles. Just convert into moles. Okay, so N2 is equal to 320 into 10 to the power of minus 3 moles. Now let me substitute it here. Okay, final molarity is equal to N1 is how much? 40 into 10 to the power of minus 3 plus 320 into 10 to the power of minus 3 divided by, what is the total volume here? 1200 ml. I can't keep it in ml. I should convert it into liters because I have taken everything. I have to take finally everything into liters. That is the reason, though I took in ml here, I have converted at last into normal moles. 1200 into 10 to the power of minus 3. Now final molarity is, if I take 10 to the power of minus 3 as common here, 40 plus 320 divided by 10 to the power of minus 3 into 1200. I can cancel out 10 to the power of minus 3 and 10 to the power of minus 3. So it will be equal to 360 divided by 1200. I will cancel out 0, 0, 12 3s are 36, 12 10s are 120. So how much will I get? Final molarity is equal to 3 by 10, that is equal to 0.3 molar. So your final molarity of the resultant solution, which is formed by mixing 0.1 m molar NaOH solution whose volume is 400 with 0.4 molar NaOH solution whose volume is 800 ml. What is the final molarity of the resultant solution? My final molarity is 0.3 ml. Most of the times number of moles will not be directly given in the question. So you need to get the number of moles of the individual solutions by multiplying the respective molarity and volume. So this is how we do the numericals for the topic molarity on mixing of solutions. Hope you have understood this session. So this is all about molarity. First we have seen molarity, then we have seen numericals on molarity, then we did molarity on dilution. Today we did molarity on mixing of two different solutions of different concentrations. Hope you understood the session and loved the session. In the next session, we will be seeing the next concentration term, which is molality. Till then, bye.